Hello friends, welcome to Kranthi Physics Tutorials. So today we have to discuss about the another very important question from your second year physics. So that is potentiometer. So potentiometer is also one of the most important questions from your second year physics textbook. Okay, so first of all, what is the potentiometer? So potentiometer, it is an apparatus. Potentiometer, it is an apparatus. It is, what is the use of potentiometer? It is an apparatus to use it to measure the EMF of a cell. It is used to measure the EMF, electromotive force of a cell. And it is also used to measure the potential difference between 2 points. Potential difference between 2 points. So potentiometer, it is an apparatus. It is used to measure the electromotive force EMF of a cell, and it is also used to measure the potential difference between the 2 points. So in an electric circuit, so it is used to measure the EMF, and also it is used to measure the potential difference between the 2 points in an electric circuit. Here the very important point is to measure these readings accurately. So to measure the EMF of a cell, or to measure the potential difference between any 2 points in an electric circuit, measures accurately. We can measure accurately by using the potentiometer. So here EMF, what is the EMF? Electromotive force. What is the meaning of electron? So maximum potential difference is called as the EMF. So whenever the cell is in an open circuit, or the cell is not connected to the circuit, so then no current is drawn from that circuit, drawn from that cell. So then we called it as the cell has maximum potential difference. That maximum potential difference is called as EMF, electromotive force. So here instead of voltmeter, so generally we use to measure the potential difference between any 2 points. Generally we can use voltmeter. But here instead of voltmeter, here we can say that the potentiometer is also used to measure the potential difference between the 2 points. So here the potentiometer measures the EMF or potential difference between any 2 points. It can measure accurately, but voltmeter doesn't measure the potential difference accurately. So why? Because I will explain with this small example, a little example. So that is, for example, so through a wire, a current I is passing through a wire. So if at these 2 points, point A and point B, if we can need to measure the potential difference, so at point A and point B, we can connect the potential voltmeter here. So then, so whenever the current A is reached to the point A, so some of the current is splits into and goes through this direction, but the most of the current, 90% of the current is passing through straight line, but some of the current, 10 to 15%, 5 to 10%, very little bit current is splits and goes in this way. So that's why the potential difference does not measured accurately by the voltmeter here. Why? Because it is depends on the direction of the current, and some of the current will be passing through the splits into the and passing through the voltmeter. So that's why the voltmeter doesn't measure the voltage potential difference accurately, but the potentiometer measures the potential difference accurately, potential difference accurately, and also EMF of a cell is also measures accurately. So that's why we need to use the potentiometer. So using potentiometer, compare the EMFs of two cells. So this is our task. So for this one, we can draw the diagram of the potentiometer. So look at the board carefully how I can draw the diagram. Okay. So first of all, potentiometer okay. So here actually the potentiometer has a very long lengthy wire. It has a very long lengthy wire. So that's why we can cut the wire. We can cut the wire into equal pieces, and those wires are connected to strips. The bold one are the strips. So those wires are connected like this. These are strips. These are strips. So here this is the point A. This is the point C. I can consider. So now for this, I can so this is point A. So this is point C. Very high resistance battery and a resistor and a key switch is connected to this circuit. So this is point A and this is point C. So the left side portion of the diagram is called primary circuit, and the right side portion, the AC from A to C, the right side portion is called as the secondary circuit of the potentiometer. So this is the primary circuit, this is the secondary circuit. So in the primary circuit we can connect the high resistance battery, and here we can connect the variable resistor or rheostat, variable resistor or rheostat, and we can also connect the switch using the switch here. So whenever the switch is open, the key is open, that means the switch is in off position, so there is no current is passing through the potentiometer. So if the switch is closed, so the current is passing through the potentiometer. The circuit is completed, then the current is passing through the potentiometer. So but here our task is using the potentiometer, so compare the EMFs of two cells. So using the potentiometer in this question, we can compare the EMFs of two cells. So that's why here we can connect the two cells. We can connect the two cells. So those cells are having EMFs E1 and EMF E1 and E2. So EMF E1 and E2. So two cells are connected. So here two cells. The first cell has EMF E1, the second cell has EMF E2. Two cells are connected from point A to a two-way key. Here this is the two-way key. So this box 1, 2, 3. So total 3 keys are there. This is called two-way key. So from this two-way key we can connect a galvanometer here. So through this two-way key we can connect the galvanometer here. So and so this is called jockey. So this is called jockey. So this jockey is connected through the galvanometer, and the jockey is slide over on the wire from A to C. So this is the diagram for the potentiometer. to compare the EMFs of two cells. So our task is to compare the EMFs of two cells. So that's why this is the primary circuit. So for the secondary circuit, so we can connect the two cells through a two-way key and through a galvanometer, and a jockey is connected, and the jockey is slide over on the wire from A to C. So here you can must and should remember the working principle of the potentiometer. So on the based on which principle the potentiometer works, so here we must and should remember. What is the working principle? The potential drop across any portion of the wire is directly proportional to the length of the wire. So here we can slide over the, so here this is the jockey, okay, so jockey looking like this. So from A to C, so we can just slide over moves the jockey from A to C. So whenever the jockey goes away from the point A, then the potential is dropped in the galvanometer. So the jockey, just we can like this, we slide over the jockey like this. So the jockey is moving away from the point A, then the potential in the galvanometer will be dropped. So that's why the working principle of the potentiometer is, so here how much potential is dropped, so that potential drop is directly proportional to the length of this wire, so we can measure the length from point A to where the potential is dropped, and the galvanometer shows null deflection. So that's why so whenever we moving away from the jockey moves away from the point A, then the potential is dropped in the galvanometer gradually. So that's why we called the working principle of potentiometer is the potential drop is directly proportional to the length of the wire. So this is the very important. So based on this principle, the potentiometer works. So here our task is we compare the EMFs of two cells. So for that, first of all, we can connect the first cell. We can connect the cell 1. It has the E1 EMF. So cell 1. So for that, the 1 and 3. So in a two-way key, the 1 and 3 are connected. So then the cell 1 is now connected to the circuit, and we can close the key or we can switch on. So then the circuit is runs. Then some current is drawn from the cell. So initially we can connect the cell 1. How we connect the cell 1? In a two-way key, the 1 and 3 are connected with each other. So then the cell 1 is connected to the circuit, and the key is closed. Whenever the key is closed, so some current is drawn from this cell, and the current is passing through this entire circuit. Okay, so now we can slide over the jockey, we can slide over the jockey like this, and some point, that point we consider as N1. So at some point we can slide over the jockey from point A. So at some point N1, the galvanometer shows null deflection. Null means zero. So zero deflection. That means the galvanometer doesn't shows any reading. So from point A to point N, so whenever we can move gradually away from the point A, the potential is dropped in the galvanometer gradually, and finally at point N1 the galvanometer shows null deflection, zero deflection. So then we said to be the total circuit is in balanced condition. So now we can measure the length from A to N1. So the AN1 can be considered as the length L1. So from A to N1, so at how much length the potential is dropped to 0, so that length can be considered as L1 from A to N1. So here we have a closed circuit here, A, N1 galvanometer and 3, 1 and E1 cell 1 and again goes to point A. So A, N1, G, 3, 1, E1 and A. So this is a closed loop we have here in this case. So now we can apply the Kirchhoff's loop rule to this closed loop. So we can apply the Kirchhoff's loop rule to the loop. So here we have A, N1, G, 3, 1, A. So A, N1, G galvanometer, 3, 1, E1 and A. So here we have a complete loop, 3, 1, E1, A, 3, 1, E1, A. So for this closed loop, we can apply the galvanometer. We can apply the Kirchhoff rule. So for this closed loop, we can apply the Kirchhoff loop rule. So then what happened from A to N1? So what is the length of that one? So 5L1. So here the 5L1 length can be taken as positive and plus galvanometer shows null deflection, that's why we can take 0, and according to Kirchhoff's loop rule, so we can goes from right side to left side, negative terminal to positive terminal, so that's why we can take negative EMF. So we can goes opposite to the current, and here from negative terminal to positive terminal, so we can move. So that's why here we can take minus E1, it is equal to 0. So we can apply the Kirchhoff rule, then we get 5L1 plus 0. Why? Because galvanometer shows 0 reading, so that's why we can write 0, and here E1 minus E1 we can take here, so it is equal to 0. Here what is the phi? Phi is called potential drop per unit length. So here L phi, the Greek letter phi is called as potential drop per unit length. So in this portion of the wire, per unit length how much potential is dropped, that is denoted by the letter phi. So that's why here we can write phi. So phi L1 and 0, so minus E1 is equal to 0. So this is the equation we get after we applying the Kirchhoff loop rule to this closed loop. So from this equation what we can write? So E1 is equal to 5L1. This is the equation number 1. So E1, EMF 1 is equal to 5L1. So this is the minus E1, right? This is 0. This is 5L1. So that's why if you can write E1 on right side, then E1 equal to 5L1. So finally we get E1 equal to 5L1 after we applying the Kirchhoff loop rule to the first loop. So now we can connect the second cell to the circuit. So that's why we can remove the connection from the 1 and 3, and then we can connect the 2 points, that is 2 and 3. We can connect the points 2 and 3 in a two-way key. So then the E1 cell will be removed from the circuit and the E2 will be active into the circuit. Then we can close the key, then the circuit is completed and the cell draws some current to the current is drawn from the cell into the circuit, the current is passing to the circuit. Now again the same process will be repeated. Now again the jockey is placed at point A and we can move along the length of the portion of the wire. At some point at some point N2, at some point N2, at some point N2, the galvanometer shows null deflection again. So for the second cell, whenever we moving away from the A point A, so we slide over the jockey on the point A, then at some point, that point is considered as N2. So at point N2, the galvanometer shows null deflection. So that's why now the total circuit is balanced. So here the length of the portion of the wire A to N2 can be considered as AN2, can be considered as L2. The length of the wire can be considered as L2 here for second cell. So now in this case also we have a closed loop, that is AN2 G3 to E to A. So for this closed loop also we can apply the Kirchhoff's loop rule. So we can apply the Kirchhoff loop rule to AN2 G3 to E to A loop, to the loop this. So AN2 G3 to E to and A. So for this closed loop, so if we can apply the Kirchhoff loop rule, so then what we get? So AN2 can be considered as phi L2 plus galvanometer shows null deflection 0, and so we can goes from negative terminal to positive terminal. So that's why we can write minus E2 is equal to 0. So from this what we get? E2 is equal to phi L2. This is the equation number 2. This is the equation number 2. So whenever the first cell is connected, we get EMF of the first cell equal to phi L1, and whenever the second cell is connected, we can get the equation EMF of the second cell is equal to phi L2. So our task is to compare the EMFs of two cells. So that's why from equation 1 and 2, from equations 1 and 2, so what we can write from equations 1 and 2, what we can write? EMF 1 by EMF 2 equal to phi L1 by phi L2. So E1 by E2, EMF 1 by EMF 2, E1 by E2 equal to phi L1 by phi L2. So here phi are both are cancelled. Phi both are cancelled. So then finally what we get? So EMF 1 by EMF 2 equal to L1 by L2. So E1 by E2 equal to L1 by L2. So this is the comparison of the EMFs of the two cells using the potentiometer. So this is the question for potentiometer that is used to compare the EMFs of two cells. The final expression is E1 by E2 equal to L1 by L2. Okay, is it clear everybody? So this is about potentiometer. Okay, thank you.